First up today, we have NOVONIX, ASX code of NVX, and they have a current market cap of around $350 million. NOVONIX provides revolutionary solutions that enable the adoption of clean energy through the development of innovative technologies and high-performance materials to service the electric vehicle and energy storage marketplace. A very warm welcome from the US. I know it's very late over there, Chris, to NOVONIX CEO, Dr. Chris Burns. Welcome.
Great. Thanks, Paul, and great to be back here with folks this morning. So I'm excited to give an update on the company. We've had a lot of exciting progress, especially in the last few months, on different areas of our business. And so with a short update, we'll go through a few of those things and what they mean for the company moving forward. So if we look at the next slide, it's just our information and disclaimers that people can review after. But the next slide outlines NOVONIX's focus. As Paul said, we're providing revolutionary solutions to the battery industry. We really view ourselves as a leading US-based battery materials and technology company focused on cleaner process technology for the localization of the supply chain. And that's what we're being driven by. The transition to electrification within the vehicle market and energy storage market are demanding huge increases in raw materials to produce batteries and localization of those materials. Over the past 10 years, we've developed significant intellectual property portfolios around the processing to make synthetic graphite a key battery material, and as well in the more recent years have developed an all-dry zero-waste cathode synthesis technology and provide updates around both of those big areas of focus for the business. At the backbone of the company is our Battery Technology Solutions Group, which started 10 years ago, and it really gives us a competitive edge as we look at the ever-dynamic landscape of battery technology and how we work across the entire industry, have full battery pilot lines and testing capabilities to support our materials program and look for growth areas for the future of batteries. And we're living in a time now with customer financing and government support, and especially the local markets such as the United States through the Inflation Reduction Act, that are paving a very clear way to profitability as we scale a new industry here in the Western world. So if we look at the next slide, we have three primary areas within our business that I just touched on: our Battery Technology Solutions Group, our Cathode Materials team, and our Anode Materials division. And last month, we had exciting announcements across each of those. And with the short bit of time we have today, we'll go across those. Our Battery Technology Solutions Group has different areas of focus from hardware to services, and now increasing in our data and analytics side, and announced the partnership with Sandbox to work on how we can leverage their AI capabilities to link material science into battery performance and really focus on how we can continue to accelerate the pace of research and development and commercialization of technologies. In our Cathode Materials team, we announced the results of a third-party engineering report, which highlighted the benefits, both technical, economic, and environmental, of our process technology, and I'll speak about that at the end of the presentation. And a huge milestone within our Anode Materials division, which is the biggest area of focus right now, as we hit key production milestones within our first mass production site and our new breakthrough technology around continuous induction-based graphitization of synthetic graphite. And we'll talk about that as we go through the presentation. So on the next slide, I mentioned our Technology Solutions Group. We like to highlight this as a big differentiator for NOVONIX, where we will grow material revenue in the coming years from our battery material sides of the businesses, anode and cathode. But our Technology Solutions Group really serves as the core research and development and backbone of the company, keeping us at the forefront of battery technology. It started 10 years ago around our ultra-high precision coulometry testing hardware to shorten the research cycle and evaluating the longevity of new battery materials. And now we've grown a huge R&D services team where we work on materials development, cell prototyping and testing, not just to support our activities, but a range of customers across the industry. And as I mentioned, our partnership with Sandbox is looking to leverage all of this data we've collected over the past 6 years of doing all of our own accelerated internal R&D into continuing to link all of our information to move our materials programs in both cathode and anode faster as we look at commercializing for the growing market here in North America. On the next slide, we'll look at our Anode Materials business. We started this group 6 years ago with the focus on the left that you see around localization of supply of a key battery material, synthetic graphite, which represents the majority of anode material used today in the battery market and will be for the foreseeable future. We need high performance products here in the Western world where the battery market will be driven by tier ones focusing on the electric vehicle and energy storage segment. And an important differentiation is that we cannot rely on the historical technologies used in China because we need cleaner, more efficient technologies that can be scaled here in the Western world. And we have to do that not by working individually, but by partnering across the industry, upstream and downstream. And we've had huge success in doing so over the past 6 years. And some of those partnerships highlighted on the right here, including most recently an investment from LG Energy Solution, a supply agreement that we signed with Core Power to begin production to supply their gigafactory that's being built in Arizona, MOUs with Panasonic and Samsung. Our largest shareholder is Phillips 66 that made a $150 million investment in the business 2 years ago, and technology partners such as Harper around our innovative graphitization technology, which I'll talk about in a moment. On the next slide, we see one of the huge progress milestones that we've been making across our path to production. 6 years ago, we focused on how we could develop the new process technology to make premium grades of synthetic graphite here in North America, and have taken that from lab to pilot to now mass production scale. 2 years ago, we purchased the facility you see on the left here, our Riverside facility. We had an opening ceremony with Secretary of Energy Jennifer Granholm, and we plan to begin production out of this site late next year. But we've been starting to install mass production equipment after retrofitting this facility for our needs. Over the past 18 months, have been optimizing the performance of key process technologies such as our graphitization furnaces. And on the right-hand side, you see pictures of these two of our continuous graphitization furnaces, which are what we believe to be first in the world breakthrough technology in terms of lowering the cost and environmental footprint of graphitizing petroleum coke into these premium grades of synthetic graphite. And the progress that we've made over the past 6 months especially has seen us produce our target specifications for the materials coming out of these furnaces, as well as hit our engineering targets in terms of the throughput, cost, emissions, power consumption of these machines. And this is giving us a path to expand the potential production out of this facility from an initial estimated 10,000 tons to up to 20,000 tons of production, which we'll confirm through engineering in the first quarter of next year. On the next slide, we look at a little bit of data coming off of this. Again, first in the world technology to continuously graphitize material at ultra high temperatures, around 3,000 degrees Celsius, with high product consistency, which is shown here in the degree of graphitization of the material over extended periods of time. Here's a production campaign of over 130 hours of continuous runtime data. And so as we approach beginning start of production late next year, as the market really takes off in 25, 6, and 7 here in North America for the electric vehicle demand, we have time ahead of us to optimize all of our operational performance and outfit our Riverside facility to reach the demand that our customers have. And if we look at the next slide, on the back of this progress that we made, we've released the unit economics that we expect to produce from our Riverside facility, which are highlighted by sales targets that are in the range that are necessary for the tier 1 auto sector, government subsidies such as the 45X production tax credits, and operating cost structures that allow us to generate strong margins and returns within these programs, with further upside benefit from potential programs within the US government policies, such as the Section 301 tariffs and the need for local compliant material for vehicle production tax credits. On the next slide, we look at our growth plans for our anode materials division. I mentioned we'll start at a 3,000 ton per year run rate at the end of next year out of our Riverside facility to support Core Power. And then we have plans to build subsequent sites with greenfield facilities to try to reach 150,000 tons of production, which only represents about a 12% market share here in North America by the end of this decade. So the demand for these materials is huge in the local markets. And there's very few people doing it because it's such a Chinese-dominated industry. And we have strategic partners in a path to production now to begin next year. So the last minute or two, I want to change gears into our cathode technology on the next slide. About 3 years ago, we started filing patent applications around an all-dry, zero-waste cathode synthesis technology to displace the complex wet chemical process of producing high nickel cathode materials. And over those 3 years, we've worked this from the university level to internal small scale kilogram pilot to now a 10 ton, per year nameplate pilot line within our battery technology solutions group, which has given us enough operational data in order to engage third-party engineering to look at the benefits of this process technology. And so on the next slide, we see the results of a study that we had commissioned by Hatch Engineering, comparing our process technology to the current state of the art of high nickel cathode synthesis. And the findings there were a reduction in the capital intensity by about 30%, the operating cost by about 50%, which you have to recognize the metals represent about 90% of the cost of these materials, but a 5% cost savings in one of the most expensive components of the battery is still a huge opportunity in this industry. And all of this being powered by a more environmentally friendly process with no wastewater from the processing streams, no solid byproducts, and lower power intensity. So we view this as a very exciting path forward for the company as we continue to build our IP portfolio around this and look at commercializing through partnerships and licensing models. And so the last slide to wrap up, NOVONIX is in a very exciting position, continuing to stay at the forefront of product technology and being a recognized leader in this space. And over the next 6 to 12 months, we'll be focused on scaling our anode materials production and commercializing our all-dry zero-waste cathode synthesis technology while continuing to develop IP in key areas across the battery landscape. So with that, I want to leave time for a few questions, quickly getting through an update across the company.
You did a great job there, Chris. Chris, I took the liberty yesterday. You gave a business update to the market, and one of the slides you had on there was with regards to the advantages of your advanced furnace system versus some of the traditional furnaces used by the Chinese. Can you just talk a little bit about those advantages to us?
Absolutely. Traditional graphitization, especially in China, is done through ash-system furnace technology, which is about a 100-year-old resistive furnace that the way they're operated today is very power intensive and has almost no emissions controls. And this is simply not a technology that's scalable here in North America. And so when we started 6 years ago, I had just left 2 years at a position with Tesla focused on the graphite supply chain and saw this as a huge opportunity for innovation to displace an archaic process and allow us to scale something with what we will build is next to zero emission facilities to produce these same quality of products at competitive cost structures. And so it's a huge opportunity and a huge breakthrough for us to be delivering on these continuous systems.
And Chris, how is your progression with customers towards supply contracts?
I think we're progressing very well. It's a very complex space because we are making the market here in North America for synthetic graphite. And we have the tier ones coming in. And of course, an investor such as LG to partner in a joint development agreement intended to lead to a first-term 10-year offtake upon completion really speaks to our position in the market. But we work with product programs with all of the major tier one cell manufacturers and are progressing very well in both commercial, technical, and also potentially financing opportunities for them for our business moving forward.
And you had a slide on this earlier, rapid growth through the company, 3,000 tons to 50,000 tons. What are your plans to help finance this growth?
One of the biggest areas for financing opportunity right now in North America is from the government. We were selected for a $150 million grant last year, which we're in hopefully the final negotiation stages with the Manufacturing and Energy Supply Chains team. And we have an application with the Department of Energy Loan Programs Office, which has been invited to diligence. So these programs can support up to 80% of eligible cost in Treasury rate debt guarantees. And so, of course, leveraging those types of opportunities is a huge area of focus for the company, as then we look to also bring customers and then potentially other forms of debt and equity into these programs moving forward.
And just with those, the grant program and the loan programs, there's a huge amount of work, due diligence that is done. They take time, Chris, don't they? I know people get frustrated, or they announced that 8, 9, 10 months ago, but there's a lot of steps and hoops you have to get through before that they are finalised. Is that a correct statement?
Absolutely. The government here is doing an amazing job in trying to stimulate this industry, but they're also trying to work at a magnitude and a speed that's almost unprecedented. So we're not anomalous in the idea of approaching hopefully the end of negotiating this award, even though it's been a 12-month process. and the diligence process and all of the work in the loan programs process to reach the stage of actually having a project invited to diligence is significant. And you have to be able to show your engineering, your path to production, your commercial relationships, which we're able to do through Riverside, our existing site, as well as partnerships with these key folks like Phillips 66 and LG and others.
And what's your view on the graphite market with supply in China increasing and potentially a slowdown in EV demand?
We've certainly seen supply in China increase, both natural and synthetic graphite, and the spot market prices have come under pressure because of that. But we have to look at the United States as a bit of a microcosm from the Chinese market, because with the government programs such as 45X, which was referenced in the unit economics slides and Section 301 tariffs, these programs put huge premiums on the ability to produce in the local market, and therefore having technology that can produce in the local market is critical. And so while we may see ebbs and flow in demand in the interim as we really reach the growth stage, the transition to electrification is clear, and the ramp coming in 25, 6, and 7 in North America is at this point unstoppable. And so I think when we look back in a few years at these times of slight turbulence, they're going to look like a blip on the radar of a huge growth curve.
Chris, really appreciate your time today. There are a few other questions that we haven't answered. If you could answer those afterwards, that'd be really much appreciated. But once again, thanks for joining us today at the late hour.
Absolutely. Thanks, Paul, and thanks everyone for tuning in.